Now we're going to talk about solving using a USubstitution. And this is what we're going to use to solve equations that may not be quadratic but are quadratic in form. What does it mean when we say quadratic in form? If we're talking about, a quadratic equation is one that can be written in the form ax squared plus bx plus c equals 0. Quadratic equations that are quadratic in form, what they have in common is that if you square the variable part of the middle term, so whatever is here, if you square that and you get the variable part of the first term, then we can say, and again, if it's in descending order, then we can say that it is quadratic in form. So before we actually do this, let's talk about or do a few examples where we're trying to recognize whether or not we've got something that's quadratic in form. So if I'm looking at this first equation, x to the third minus 3x squared plus 2 equals 0, and trying to decide if it's quadratic in form, I'm going to look at the variable part of the middle term. If I take that variable part and I square it, do I get the variable part of the first term, which is x to the third? And that answer is no, right? This would have to be x to the fourth for this expression to be quadratic in form. So this is not quadratic in form. Here, if I want to solve this equation, if I take the variable part and I square it, if I square x to the third, I get x to the sixth. So this does not match this, therefore this equation is not quadratic in form. Next one, if I take my x to the 1/2 and I square, x to the 1/2 squared, when we raise an exponential number to a power, we can just multiply those powers together. 1/2 times 2 is just 1. And x to the first power is x. Therefore, this guy is an equation. It's not quadratic. It can't be written in the form ax squared plus bx plus c equals 0, but it is quadratic in form. Okay, this is quadratic in form, as is this. And, right, if we square our x squared, we're going to get x to the fourth. And if we're looking down at this equation here, if we were to go through the process of simplifying, so squaring this binomial and distributing the 3, combining like terms, doing all of that, we would actually have a quadratic equation. This is a quadratic equation, but we can also say it's quadratic in form. We see if we take this guy right here and we square it, then we will get this guy here. And so when we recognize that we're dealing with an equation that has this property where squaring the variable, and I say that with quotes around it, when I square the variable part of the middle term, I do end up with the quote-unquote variable part of that first term. And so if we are dealing with equations that are quadratic in form, then we can solve them using a USubstitution. Going back a minute, at this point, at this stage of the game, we haven't learned any methods for solving an equation that looks like this, or solving an equation that looks like this. We've dealt with solving linear equations, and we've dealt with solving radical equations, which I guess this is. We could have used our methods from Chapter 9. But, we've never really talked specifically about solving these different types of equations. If you do have an equation that's quadratic in form, then what you can do is you can solve using a USubstitution. So what we're going to do is we're basically going to take the equation that we have and make it look like a quadratic equation so that we can solve using the methods of quadratics. And then once we know what the value of u is, then we're going to go back in terms of our original variable. So let's look at this guy here. So here we want to solve the equation x to the 6th minus 3x to the 3rd plus 2 equals 0. Okay, so this is not a linear equation. We don't have just x to the 1st power. It's not a quadratic equation, but if I square my x to the 3rd, I will get x to the 6th. So because of that, this equation is quadratic in form. And if an equation is quadratic in form, then we can use a u substitution to solve. We're just going to substitute u for the variable part of the middle term. So instead of writing x to the 3rd, I'm going to put a u in its place. I'm basically going to take my x to the 3rd and let it equal u. Okay, so if x to the 3rd is u, then x to the 6th would actually be equivalent to u squared. So rewriting this equation, I'm going to have u squared minus 3u plus 2 equals 0. The purpose of doing this is now that we have an equation that we're familiar with. We have a quadratic equation. And so quadratic equation, the methods that we've been talking about, we can solve by factoring, by extracting the root, completing the square, or the quadratic formula. I can see that this is something that's easily factored, so I'm going to go ahead and do my factorization. So if I factor, it has to be that the first times first is equal to the first, so u and u. This guy times this guy has to give me positive 2, and my inner and my outer have to add to negative 3. So to multiply to a positive 2, I have to either do a positive times a positive or a negative times a negative. Due to the fact that I want my inner and outer to add to a negative, I'm going to choose negative, negative. So if I try minus 2 and minus 1, negative 2 times negative 1 does give me positive 2. When I multiply my inner 2 together, I get negative 2u. My outer 2, I get negative 1u. And negative 2u minus 1u does give me negative 3u. So this is the correct factorization. Again, just reviewing as we go here, I'm going to erase this stuff. When we solve by factoring, the reason we do that is so now that we have this times this is equal to 0. And so remember, the only way, if we're doing a multiplication, the only way we can end up with a product of 0 is if the factors are 0. So the solutions are 2 and 1. Because if u is 2, this is 0, and 0 times anything is 0. If u is 1, then this is 0, and anything times 0 is 0. Okay? So, based on this, we found the solutions for u. But if we go back to our equation, it said solve this. When we're solving this equation, the variable in this equation is x. So my answer has to be values of x that make this true. Okay? I have not found that. And so once you've found the values for u, then you need to solve to find the values of the original variable. Okay? U, we let replace x to the 3rd. So if we say u equals 2 and 1, that's like saying x to the 3rd equals 2 or 1. So I have x to the 3rd can equal 2, or x to the 3rd equals 1. And so now to solve for x, I have two different equations. And now you're going to have to pull from everything we've been discussing so far. So if we have x to the 3rd equals 2, and we want to solve this equation, we have to get rid of this cubing, and we do that by taking the cubed root of both sides. So we're going to take the cube root of both sides, and so this gives me x equals the cubed root of 2. Same thing over here. Solving that equation, we get x equals the cube root of 1 is 1. So the solutions are cube root of 2 and 1. This guy, again, you could, if you wanted to, go through the whole process of simplification and then go from there. But easier, looking at this, you see that if you take this guy here and square it, then you're going to get this guy here. So anytime that is the case, you can use a USubstitution to solve. Okay, so rather than going through a big ugly simplification, I'm going to choose to use a USubstitution instead. So I'm going to take my x minus 3 and I'm going to let it be u. So rewriting, I have u squared plus 5u plus 4 equals 0. So in comparison of the two, this is definitely much easier on the eyes, and it should be pretty easy to solve from here. U squared minus 5u plus 4, that is factorable. I can factor this into u minus 4 times u minus 1, right? If I multiply u times u, I'll get my u squared. My negative 4 times my negative 1 is a positive 4. And my negative 4u minus 1u, that is negative 5u. So based on the factorization, for this product to equal 0, u must be either 4 or 1. Okay? But it's not u that we're trying to solve for, it is x. Okay? Saying that u is equal to 4 or 1, remember, you just replace this x minus 3. So this is the same thing as saying x minus 3 is equal to 4 or 1. So x minus 3 can either equal 4 or x minus 3 can equal 1. And now we just have to solve these equations to find out what the value of x is. So this is a linear equation. I'm just going to add 3. So I get x equals 7 over here, adding 3 gives me x equals 4. So my solutions are 7 or 4. X to the fourth minus 13x squared plus 36 equals 0. So again, if we square this, we will get this. Therefore, a USubstitution is something we can use. So I am going to let my x squared be u. And if x squared is u, then x to the fourth can be u squared. And we can go from there. So we have u squared minus 13u plus 36 equals 0. Trying to solve this again is also factorable. We can factor this into u minus 4 times u minus 9. And so we end up getting u equals 4 or 9 as our solutions. But again, it's not u that we're trying to solve for, it is x. So instead of u, I need to put that back as x squared. So u equals 4 or 9, saying x squared equals 4 or 9. So we have x squared equals 9 or x squared equals 4. And now we have these quadratic equations that we want to solve. So to solve for x, we need to get rid of that square. And we can do so by taking the square root of both sides. So we have x equals plus or minus the square root of 9, which is 3. Remember, anytime if you have basically a fourth or a square or a fourth or a sixth, anytime you're dealing with an even index, when you take, if you take the square root of both sides or the fourth root, that's when you're going to need the plus or minus, because of the fact that you can multiply a positive number twice and get 9. You can multiply -3 twice and get 9. Okay, same thing works if it's 4. If you multiply a positive number 4 times, you're going to get a positive. If you multiply a negative number 4 times, you're also going to get a positive. So if this power is even, you're going to need the plus or minus. If it's odd, you will not. So again, taking the square root of both sides here, we have x equals plus or minus 2. So my solutions are 3, -3, 2, and -2. And this isn't unexpected. I mean, looking at the equation we have here, the degree of this equation is 4, so we can expect up to 4 real solutions, and we have them. Okay? You don't have to have 4 real solutions, but you can have up to 4. Solving this again, and this is very similar to what we had when we were looking at, is it quadratic in form? If we look at this guy here, if I take my square root of x and I square it, I do get x, which is the variable part of the first term. I actually get the absolute value of x, but we're not going to worry about that right now. So this guy is quadratic in form. So we're going to let the square root of x equal our u, or our u equal our square root of x. It doesn't matter, same thing. So what we have is u squared minus 13u minus 30 equals 0. Again, this is factorable. Don't make the mistake of thinking it should be 10 and 3. This is one of those that people mess up all the time. When you're doing your factorization, again, this guy times this guy has to equal u squared, so it has to be u and u. This times this has to be -30, and our inner and our outer have to add to -13u. Okay, the most common mistake people would make is do -10 -3. Why does that not work? -10 times -3 is not -30, it's +30. Okay, this is not the correct factorization. What is the correct factorization is u minus 15 times u plus 2, because first times first is my u squared, my -15 times my +2 is -30, and -15u plus 2u, I do get -13u. So my solutions are 15 and -2. These are the values of u, but remember, we let u replace the square root of x. So we have the square root of x equals 15, or the square root of x can equal -2. Solving each of these equations, squaring, I have x equals, what is that, 225? Or, coming over here, squaring this, I get x equals 4. But 4 really isn't a solution to this, because if you go back and check, is it true that the square root of 4 is equal to -2? No, it is not. Okay, 4 is actually an extraneous solution. If you plug it into the beginning, it won't work either. If you have 4 minus 13 times the square root of 4, the square root of 4 is 2, and 13 times 2 is 26. So you would have 4 minus 26, which is -22, minus a 30, does not equal 0. So this is an extraneous solution. Again, anytime you're solving a radical equation, you do have to check for extraneous solutions. If we substitute the 225 in, you will see that it does work. Okay, we'll have 225, and I can just type it all in. Can you see my calculator? 225 minus 13 times the square root of 225 minus 30, and it does equal 0, which is what we have in the equation. So 225 is a solution. Okay, so that's solving using a substitution. It might be something where you might want to try to practice it a little bit and then come back and watch the video again. And usually this is one of those that definitely gets clarified the second time around after you've worked on it a little bit. Let me know if you have any questions. Talk to you later.